In this video here, we're going to be looking at the concept of the derivative. Essentially what it is that you are finding the gradients on a graph at one single point. So not when there are two coordinates, but when there are two coordinates that are very, very close, essentially that they will become one coordinate. And so when we go to find these, we need to understand an underlying concept first, which is about finding the limits, which is when a particular value approaches 0. In this case here, we're going to talk about h. And if h approaches 0, then essentially you're honing in onto a single point. The purpose of limits have many different applications and case scenarios. However, in this case here, we are just going to learn how to apply the function that is a limit. So the limit does something to whatever's inside the bracket. Essentially, you'll see that the limit is essentially just substituting in this h value here when h approaches 0. They are evaluated by substitution. However, you must simplify the expression before you substitute, particularly in these examples here where there is a h in the denominator. If you substitute it immediately, then it will be h over 0, therefore becoming undefined. So in this case here, we're going to go ahead and try these examples first. In the first example, we can see that there is nothing that we can simplify or further simplify within that bracket. So we say we are going to apply the limit now into this bracket here. When we apply the limit, essentially what you are doing is that you are substituting h equals 0. Not the x value, just the h value. Now this here seems like a trivial task. However, once we go to more complex cases, particularly when you are differentiating using first principles, which we will see in the next video, you will be working with something more abstract. So, in this case here, there is no h inside the bracket. If there is no h inside the bracket, then the bracket stays as it is because it is untouched. In this next example here, which I will do in a different color, we can see that inside the bracket there is a fraction. This is an indicator to us that we need to simplify the expression first. So what we're going to do is we're going to divide everything by h. But before you do, this function of the limit is still not applied yet. It hasn't been applied. Therefore, we need to write it out. I'm going to split up these fractions. And in the next line, we haven't applied the limit yet. We are going to simplify the fractions. Once you're done, now we are going to apply the limit into the expression on the inside. When we apply the limit disappears and essentially you substitute for h. We end up with 3x squared. Last but not least, we have one more example on this particular page. We can see a fraction again, therefore we must simplify the fraction. The limit still stays at the front. We have not applied the limit yet. Now we are going to apply the limit. Notice we are substituting h. We are not substituting x. I have a few more examples here before we move on to the next topic or the next video. In these cases here, we are substituting the limit for x. This will help us with understand a concept later in this topic, which will relate to continuity and differentiability. And right now, it just seems like we are applying the limit into the expression because there is nothing else to simplify. In this example here, we do need to factorize first. If you do substitute in x equals -4 immediately, you will see that the denominator equals to 0, and by default that would become undefined. However, if we simplify this first, which you can see the x plus 4 in the denominator and the numerator will cancel out, you'll end up with a simplified expression of 2x. Once you have that, then you can apply the limit into the brackets, and you end up with a value of -8. In this case here, if we substitute this, we can substitute this in directly into these brackets here, so we can apply the limit immediately. We end up with the substituted expression first. $33, 110, 143. Last but not least, if you substitute in 3 immediately, you'll notice that it would become undefined. Therefore, you must simplify the expression or factorize it first. For the numerator, it is a quadratic, so we'll need to find some sort of cross for us to work with here. Factorize this quadratic expression as you see best. Then simplify the expression inside the bracket. We are left with 4x plus 1. Now we can apply the limit. So the limit disappears. We end up with 13. So essentially, this seems like a very trivial exercise here for evaluating limits. All you're doing is substituting values, but make sure you simplify the expression before you substitute the limit or apply the limit. Don't forget to pause, rewind, rewatch if you would like to revise.